Okay, welcome to another one of my video log recording sessions where I talk about genetic algorithms and stuff. Today I'll be covering the Jupyter notebook titled Genetic Algorithm Procreate Functions FXS Rev as in revised. This is kind of like a recap of the one I did previously, titled Genetic Algorithms Procreate FXS. But again, in this notebook I have implemented the new metric, which is the average of top 30% entities, and also factoring in their weights, as in how many entities there are at each summed utility value, as in the keys in the entities dictionary when the evolution is going. So that's that. And in this notebook I only have 20 items just to make things a bit easier, but and all the 10 Procreate functions, the Procreate FXS, are the same, and except that this again has been added, the compute average summed utility function, so that I can draw plots at the end of the evolution, at the end of for example 5 runs of the evolution. So, and each evolution, as stated in this cell for hyperparameters, is how many? Or not? Was it not here? Let's see. Oh, 500. So until 500 generations. So all the other hyperparameters are almost the same. Population size is 500, so max population will go up to 500 times 1.4, which is 700. And mutation rate 0.07. Crossover rate, I'm not using that right now, but it's still here. I don't know why. I just haven't fixed it, lest I need it. So far I have not ever needed it, because the crossover, well, in this case it's is it used? Is it used? Let's see. No, well, maybe it is, maybe it's not. Sometimes it is, sometimes it's not, but it's not like this variable here is absolutely needed. So 10 Procreate functions are the same: self-replicate, elitist, winner takes all, top few take all, favoring highs. And this is where the crossover happens, but it doesn't actually use the crossover always happens here, so I don't need a crossover rate in this occasion. Proportional, less favoring highs, opposites attract, birds of feather, and pure chance. So we run all these things, and while we're doing that, the values for the top entity, head, and the tail, and then the last entity, in descending order. So with the entity with the lowest summed utility value, and the average of the top 10%, the average of the top 20% are gathered and stored in this list. And the evolution is started and has been completed. Sorry, it takes about 14 seconds on my laptop. So here it will take about 42 to 4 times 52 seconds. Is it 56 rather? 3 to 4 times this time. So I don't want to run that. And here is the distribution. Well, it's a slice. It's a snapshot again of the last iteration of the evolution, which is 500 generations each, and because this is the lonely island where the top entity gets to survive onto the next generation. That's why there are so many entities with the above 700. And if you remember the best possible combination, and the result is 710. So this is actually exceptional here, but exceptional for a reason, because the top entity or top entities always get to survive, and that's why there are more than 18 or around 18 entities at the end of the evolution. And here's a graph for the top entities, the heads. So it's where the gold line is the maximum ever, which is 710, and the red line is the highest possible it can be in terms of sum due Tutsi values. So this is 710, and you see that the gold line and the red line are the same lines. They occupy the same place. So it shows that some entities have hit the 710 mark. Kind of. If you look closely enough, if you zoom in, I'm not going to do that, but if you look closely enough, the green line is actually the same as the red and gold line. So that's expected. And here are the plots for the tails. This is also expected. And here is for the top 10%, the plot for the top 10%, and they peak and plateau. Not much of a dip we can see here. So so far the purpose of exploring into the world of different Procreate functions or parent selection schemes was to minimize the size of the dips, and in this case the lonely island does seem to do that, but I can show you it does have its downsides, and I'll cover that in a future video or two. But so far, with only 20 items, there are no dips. There are no noticeable size dips. That's good. Top 20%, same, as anticipated. And the next one is the Monopoly Elitist. Again, collecting the values for heads, tails, top 10% and top 20%. And here are the assessment. And because the top entities don't get to survive for certain onto the next generation, we don't see a high number of entities above 700. We see a very high number of this, where it's slightly below 350, about 20 entities. But if we just leave that out, it's a bell curve, it's a normal distribution. So that's also kind of expected, I guess. Again, this is also a snapshot. This is the distribution of the 5th iteration. Yeah. And here are the heads. So this is also kind of decent, as all the heads are at the 700, above the 700 mark, sometimes touching 710. These are for the tails. The plots for the tails. And this picture is for the top 10%. We see that dip, slight dip, and then it plateaus to the right, outwards to the right. So there's a bit of a dip when we use the Monopoly Elitist Procreate function. Same can be seen for the top 20%, the plots for the top 20%. And we move on to the Monopoly Winner Takes All, where the top entity gets to procreate with where the top entity is always chosen as parent number 1, and parent number 2 can be any one of the entities within that generation. And here's the assessment. Somehow this time there are more entities towards the right, but overall it is a normal distribution, but it is slightly skewed to the right. I mean to the left. It's heavier on the right side compared to this. Yeah. But it did hit that maximum ever, which is 710. The best possible entity that could ever be, which is 710. It did reach that, so that's a plus. However, when we look at the plots for the heads, the plots oscillate, the lines oscillate, they're not so stable as when comparing to this, or when using the Lonely Island function. It's very unstable for the heads, and these are for the tails. Again, more unstable. Here's one for the top 10%, and they plateau slightly below 600, whereas for the Lonely Island they used to plateau above 600, and Monopoly Elitist, the plateau is again above 600. But this would be due to the fact that when using Lonely Island, there are a lot of entities at the 700 plus mark, above the 700 mark. So when we calculate the top 10% of the entities, this is about 18 entities. Top 10% of 700 is 70 entities. So these entities take a considerable portion of the top 10%, and hence the higher summed utility value, higher average of summed utility values. And oligopoly, we use that where I think in this case the top 10% get to procreate with each other, and we see that it is still kind of normal distribution, but there are some higher values at the right, towards the right. There's a higher values here, but there are occasional higher values at the 400, below 500, above 500, above 600, and so on. And there are about 3 entities above 700, so that's good. And when we use oligopoly, the heads also are quite stable. When we look at the plots, they don't oscillate. And here for the tails always seem to oscillate for some reason, but I think it's kind of obvious. And the top 10%, we see a slight dip and bigger oscillations. However, the plateau is still above 600. So oligopoly is can be said to be decent for some specific purposes. And favoring highs, here are the assessment. Again, kind of a bell curve. Yep, kind of a bell curve, and highest ever. It did reach the 710, so that's good. However, the heads, they do oscillate. It's more stable, and sometimes the best within a generation is way less, which could mean that the good ones kind of mutated and got struck out, went above the physical weight threshold and got struck out. And these are the plots for the tails. They oscillate again. Sometimes they go all the way down to 0, which means that some things just mutated back into nothing. I don't think that's necessarily the worst thing that can happen, but yeah, it happened anyway. And here are the plots for the top 10%. They oscillate and they plateau at about 600. So slightly less than oligopoly, as we can see here, and still less than Lonely Island. But that's kind of obvious, again, because in Lonely Island there are a lot of entities above the 700 mark. And also for the top 20. Proportional. Again, same values. And when we look at the distribution, yep, not straying too far away from a normal distribution curve, the bell curve. Maximum ever has been 710, so that's a good thing. That's a good sign. Here are the result list for the heads, and they are not stable. They oscillate too much. So sometimes it did hit 710, but I don't know where it did that. Or maybe here, over here in this orange line. But they oscillate too much. So it's very unstable. This is very unstable because these plots are for one singular value per generation, and they die. The top entity dies too often per generation, and in the next generation they don't. And when that happens, it seems that they don't really. The other entities that remained don't tend to mutate into a better one, which is why the best entity, the top entity, goes down and then just stays there until they come back up again just by chance, just as a result of mutating. The tails are here, and the top 10% below 600, the plateau level. So it's not as high as these 3 or 4 Procreate functions. Top 20, same. But again, the dip isn't showing, so maybe that's a good thing. But the dip is not showing because it has never peaked. Then that's bad. It's not healthy, let's just say. Less favoring highs, let's look at that. Here's the distribution. Oh, we have a really high median, or the mean thing, the mean value, kind of. It's very heavy in the center. Well, more heavier in the center than the other Procreate functions. However, we do have like 5 entities at 700. And it did hit the maximum ever, 710. And here are the results for the heads, and still kind of volatile, unstable. For the tails, even more unstable here. For the top 10%, the plateau is below 600, slightly below 600, at about 600, let's say, being generous. But we know that it could still be above 600. Top 20, nothing unusual. And opposites attract, where the entities that are different from one another get together and procreate. Maximum ever has been 705, so that's, okay, not bad. And it is very, very volatile. Not very, very, but kind of very volatile. And the tails are volatile as well, and I think they're kind of lower. And here are the plots for the top 10%. Again, the plateau is below 600 at about 550, so that's not so good. And it's not such a desired outcome, because we know it could be higher. Top 20, yeah, Here's one for the birds of feather, the assessment. Well, this is kind of interesting, as there's a huge number of entities above 500, but it's still a bell curve. So, and the maximum ever has been 705, and the heads are again the top entities, kind of unstable, quite unstable rather, and the tails are, well, as expected, but look very unstable. The top 10% plateauing at about 550 or 540. Top 20%, yeah, same thing, but not a lot of difference between top 20 and between the average of top 20 and between the average of top 10% and average of top 20%. Yeah. Pure chance, where the parents are just selected at random, so pure chance. And assessment, very much a bell curve, except this spike, but except that it is a bell curve. But we see that there's I don't think it's ever reached 700 or above. Oh wait, it has. Okay. And here are the plots for the heads. So very volatile. If you lose the information, it just dips right back down, and then it takes some time to get back up. Maybe never for the purple line. Yep. For the tails, yep, quite volatile again. And the top 10% plateauing at about 650, 640 or 650. No dip there anywhere, but again, because it never peaked. And the top 20%, the same. So these are the top. These are the 10 different Procreate functions that I have come up with. I know there can be more, and I know that I can mix and match some of them. Either I mix one function with another, or two, or mix some take one or two aspects from one function and combine that with some other aspects of some other functions. Yeah, but these are the 10 basic functions that I have devised and created, and using these functions I plan to control the size of the dips when given 30 or 40 items. I think it's yeah, I think it's, wait, how many items is it? Yeah, I think it's at I do that with 40 items. Yep. Okay. Well, that's the end. Thanks for watching. See you next time. Bye.